Hello again and welcome to my car. I bet you guys haven't had a math lesson taught from a car before. I know I've never personally driven my car into the school and taught a lesson in my car. You might be thinking, Mr. Sarah, what are you doing in the car? Well, for you guys yesterday, there's power outages in Eagle Mountain, and so I didn't have any internet. And so I thought, well, not a problem, I'll teach from my phone. But for whatever reason, my phone didn't have reception in my house. Normally does, didn't today. So we took a little trip to Walmart and just sitting in the parking lot, teaching a lesson. Who knows? Maybe one of you will drive by while I'm in the middle of teaching this lesson. If I see you, I'll wave to you, but I don't know that I'll see you guys. Anyway, let's go ahead and look at the lesson for today. It's just a whole nother adventure right here. So today's lesson is Module 6, Lesson 4, and we want to be able to solve 1- and 2-step problems using graphs. Yesterday we learned how to use a graph to scale it and to create it so that we could see the information visually. We learned that it's called a bar graph. And so now we're going to be answering some questions based on bar graphs that we have made. First, let's jump into this application problem. This application problem has 2 parts to it, and I want you guys to give it a try. So after I finish reading the question, go ahead and pause the video. Just a reminder, they're using variables down here. So where we see letters instead of numbers, that is called a variable, and it's just a place value for something that we don't know or something that we might change later. The question reads, the following chart shows the number of times an insect's wings vibrate each second. Use the following clues to complete the unknowns in the chart. Part A, the beetle's number of wing vibrations is the same as the difference between the flies and honeybees. The mosquito's number of wing vibrations is the same as 50 less than the beetles and the flies combined. So here we see we're going to have to do a couple steps. In this case, we're not doing it with a bar graph, but rather we are using the information from the chart. We're going to have to figure out what the missing information is. So this is going to be my work for part A. And I'm going to reread this part. The beetle's number of wings vibration is the same as or equal to the difference between the flies and the honeybees. So here we see the flies' number of wing vibrations each second and the number of honeybees' wing vibrations per second. Difference means I'm going to take these two. I'm going to show you guys with some number strips here, some tape diagrams. So when I'm looking at difference, I'm going to have these two, and the difference is the amount that goes right here. So if this is the number of the the flies, this is the fly, and this is the bees, I'm just going to put HB. Then this value right here is the difference between the two. So this is the variable B. Okay? And looking at it, I can write a number sentence for it. The fly's wings beat 550 vibrations a second, and the honeybees are 350 per second. And so what's the difference there? What number could fit right here that completes that? So that's going to be 200. And so my missing value, I'm going to say B is equal to 200. And I'm going to put a box on this. That's how much the beetle's wings vibrate. Okay. For part B of this question, the mosquito's number of wing vibrations is the same as 50 less than the beetles and the flies combined. So I need to figure out how much the beetles and the flies is combined. Again, I'm going to use some tape diagrams. I'm going to say this is the beetle, and this part, I'm going to put them together, is the flies. And this isn't the answer though, because I need 50 less than that. So if I take another tape diagram, and I put it up here, And I don't know how much 50 is. I'm just going to put 50 here. This is going to be M, this little diagram right here, this little piece of tape, because it is the same as the beetle and the flies combined minus 50. So let's just go ahead and do the work. We figured out what the beetles was in the last part of the question. It was 200. When I'm combining numbers, I'm going to add them together. The flies was 550. How much was that? Let's go ahead and do that step. 750. Now, that's not the end, though, because I need to take the amount combined, and I need to subtract 50 from that, because it's 50 less than those two combined. So that's the second step right there, going back to our question. So 750 minus 50, nice and easy. That's 700 vibrations per second. I'm going to put it in a little box so it's easier to see. And the number for the mosquitoes is 700. Now that I have all of the information here from this application problem, I'm going to go ahead and build a scaled graph. Now, I have a chart here, and I'm going to decide right off the bat, do I want my bars to go vertically, or do I want them to go horizontally? And I like a good vertical graph, so I'm going to make it vertical. So I've got the honeybee, the beetle, the fly, and the mosquito. I'm going to go ahead and mark this honeybee, the fly. I'm going to leave a couple spaces in between each one. The beetle and the mosquito. You know what? Let's do this. Let's put the beetle here. And then it was the fly. I'm going to have to go back and forth. The fly, 2 spaces. Fly, 2 spaces. Mosquito. I like to say mosquito in my head whenever I spell mosquito. So now I need to figure out the scale. Well, the name of this is the wing vibration of insects. So let's go ahead and title that wing vibrations of insects. Okay. The honeybee is at, so I need to figure out the scale next. If I had a scale of 1, I don't have enough. It's going to go really high. If I did 5, I could get up to 5, 10, 15, 20, 25, 30, 35, 40. If I had 10s, I'd be able to get up to 80. I'm going to go ahead and put a 0 here at the bottom. We always have a 0 at the bottom. So those numbers aren't going to work. So I need a bigger scale. So I could try 50. Let's see if 50 would fit. I need to get up to 70 as my biggest one. So when I'm trying to think of scale, I'm going to think the highest number that I need is a 70. Sorry, 700. 700 needs to be all the way up at the top so that all my information fits. So if I did 50, 100, 150, 200, 250, 300, 350, 400, that's not going to work. So let's see if a scale of 100 would work for these bar graphs. 100, 200, 300, 400, 500, 600, 700, 800. That's going to work. I'm going to be able to fit all the information. So I'm going to go ahead and put my scale over here as hundreds, 100, 200, 300. And this is the line is going to be those values. 400, 500, 600, 700, and finally 800. And this value over here, I can't really write sideways and I'm kind of out of room. This is the number of vibrations. Vibrations. I'm squeezing it in. Okay. Now we need to actually go and fill it in. I'm going to get my marker just a little bit thicker. Let's do really thick today. And I'm going to go back to my chart. I'm going to figure out the values. So the honeybee was 350. I have 300 and I have 400, but I don't have 350. So I'm going to have to go in between the two. So somewhere like right here. Fill that in. There's my bar. I'll come back in and fill them at the end. Beetles was 200. I have 200 on here. I'm gonna have weird gaps. 200. The fly, I have 550. So I'm gonna have to go in between 500 and 600. And then for the mosquito, 700. That one's gonna go all the way up here. Got some funky gaps in my graph, but as long as they're spaced apart, that's okay. I just want to know which one goes to which value. So now we're going to go ahead and color it in so that they're just even easier to see. Color that one in, that one in, this one in, and finally the mosquitoes. Now it's easy to see that the mosquitoes flaps the most, or vibrates the most rather. And we're going to be answering some questions about it. So let's go ahead and look at our first question. That's the wrong way. How many vibrations do 2 beetles and 1 honeybee produce each second? So the beetles was 200, but we want 2 beetles. So 2, oh, I still have a thick marker. Let's fix that. Let's erase this too. So there was 200 for the beetle, and there was 2 of them. I'm going to put this in parentheses. Sorry, that was 200 times 2. That's for the beetles. And a honeybee, 350. So in this case, I'm going to do this multiplication first. 2 200s, I can do 200 plus 200. I could count by 200s if I'm feeling confident. I can use my 2 facts to help me out. So 2 times 2 is 4, and these are hundreds, so it's 400 plus the 350 from the honeybee. That's going to be 750 vibrations. And that's my answer. I'm going to put it in a box. Okay, the second question. Use a tape diagram to compare how many more vibrations a fly and a honeybee combined produce than a mosquito. So first, I'm going to figure out how much a fly has. This is going to be a fly. I'm going to combine that with a honeybee. And then I'm going to compare those to the mosquito. And based on the way that the question was asked, mosquito, I know that the fly and the honeybee are going to have more because it said how many more do they have. So I'm looking for this value right here if I make the tape equal. Okay, so let's look at our numbers. The fly was this one. It was 550. The honeybee was 350. And I'm going to go ahead and say that that equals 900 over here. 50 and a 50 make 100. So I've got a 500, a 300 plus that 100 from the 50s, 900. The mosquito was 700. So I'm looking for the difference between 900 and 700. So this value right here is going to be 0, 0, 9 minus 7, 2, 200. So the difference is 200. Okay. Let's go ahead and look at this first part of the problem set. The first thing that we need to do is create a scaled bar graph. And so it says the chart below has the number of magazines sold by each student: Ben, Rachel, Jeff, Stanley, and Debbie. Now to make the scale, I'm going to look. 0 is always right down here. This bottom spot right here, this is always 0. And I've got 1, 2, 3, 4, 5, 6 spots. So knowing that, I'm going to think, what scale can I use? Can I use the scale of 50? Well, 50, 100, 150, 200, 250, 300. That's not my biggest amount. My biggest amount is right here, 600. That's the biggest one. So I know I have to at least get to 600. Let's try a scale of 100. 100, 200, 300, 400, 500, 600. That's going to work. So this first mark will be 100. The second mark, 200, 300, 400. That's a lot of magazines sold, by the way. 500 and 600. And then to make these graphs, I'm going to have to write these students. Trying to write sideways, it's kind of tricky. Ben got 300. And I don't have those little the lines to help me with this one, but I can still make these little bars. Rachel was next. I'm just going to use the letter R because I'm having a hard time. 250 is in between 200 and 300. So I'm going to put that line somewhere in between there, try to make it right in the middle. Jeff, I'm just going to put a J for Jeff. He got 100. So his number is going to be right down here. That's his bar. And then Stanley was at 450. So I'm going to put an S for Stanley. And his bar is going to go all the way up to 450. Now this is where it gets a little tricky. I'm going to try to estimate. This looks like about halfway in between those. And there's my bar graph for Stanley. And finally, Debbie, put a D for Debbie, 600. She's clear up here at the top. And now I've got my scaled bar graph completely made. And I'm ready to answer some questions. You can use the table to answer the questions. For some of us, it helps us to see the graph and be able to answer the questions based on that. Make sure when you are reading the questions that you are reading them carefully. I have a feeling that that's what's going to get most of us. Okay, so good luck on the assignment. Let me know if you have any questions. Hopefully you're not trying to do this lesson from a car, because as hard as it was to teach it from a car, I can't imagine how hard it would be to learn it from a car. I miss you guys. Keep doing great things, and I can't wait to see you tomorrow. Goodbye.